Okay, this is the second lesson of probability. Okay, let's look at some interesting scenarios about probability. One player chooses 6 out of 45 numbers, okay, if he wants to buy Toto with 6 consecutive numbers like 10, 11, 12, 13, 14, 15. Almost everyone scoffs at the logic of such a choice, okay, because they believe that the numbers are much more likely to be spread out in a non-consecutive pattern like spread out, okay, 2 to 32. So what do you think? Would other combinations have a better chance? Boy or girl? Let's say a couple gave birth to 10 girls in a row. What is the probability that the 11th child will be a boy? According to probability, the possible outcomes are just boy and girl. So boy, probability of boy is half, probability of girl is also half. So in reality, okay, probability is affected by like biological or genetic factors. Okay, so there might be a probability that the 11th child is a boy as well as a girl. Okay, next experiment. If you toss a coin 20 times, okay, like some of you have already done in class. So suppose the first 4 tosses have been hits. That's 4 hits and no tails so far. So what do you expect from the next 16 tosses? Pupil A, I still expect 10 hits and 10 tails. Since I've already got 4 hits, so now I expect 10 tails and 6 hits from the remaining 16 tosses. Okay, so in the next few tosses, I will expect more tails than hits. Next pupil, he says, there are 16 tosses to go. For these 16 tosses, I expect half-half, which is 8 hits, 8 tails. That means I now expect 12 hits and 8 tails from my original 20 tosses, which I'm supposed to carry. So, who is right? Okay, pupil B. Why is that so? Because in probability, it's a chance of a chance of occurrence of an event. Okay, so we cannot take into consideration the first 4 tosses, and we just have to consider the next 16, which you have not done it at this point. And the probability of hit and tail is just half-half. Okay, so probability is just an occurrence of an event. Okay, if the event has already occurred, then we don't have to talk about probability. Okay, so it is still using this same formula, and just take note the total number of possible outcomes that has not occurred actually. Okay, so the keyword is possible outcomes. And we've also mentioned at the end of the last section, okay, the probability will range from 0 to 1. Okay, in this part of the lesson, you will learn to draw possibility diagrams and using it to solve probability problems. Example, 2 dice problem. If you throw 2 dice, like the last section, okay, we can list out the possible outcomes. That will give you 36 possible outcomes. Okay, 6 from each die. And this is very tedious. Okay, so a more systematic and effective way of listing the outcomes, you can put it like a grid to show that there can be 36 different possibilities. Okay, so in this case, the total number of possible outcomes in this sample space is 36. Now, example, if you want to find out about the sum of the 2 dice, okay, let's work out the numbers with the sum that is an odd number. Okay, you have 1 and 2, 2 and 1, 1 and 4, 4 and 1, 2 and 3, 3 and 2, and so on. So this is very tedious to list out all possible outcomes that are odd. So we can use a more effective method, just like the possibility diagram, but instead of using the dots, we can write a plus, an addition symbol, okay, for this case, to note that we are adding the first die and the second die. So this is a sum of 1 and 1. This is the sum of 2 and 1. Okay, so you just keep adding. So the blue fonts, the blue numbers are the sum of both dice. And now the total sample space is still 36. Okay, so we will be able to answer the questions more easily. Okay, so let's look at odd numbers. Okay, that gives you half because the other half is even. Part B, the probability of even numbers. Okay, half. Okay, take note. In this case, the sum is either or even. Okay, there is no in between. And you notice that by adding the probability of odd and even, it actually gives us a sum of 1. Okay. Alternatively, if you want to do part B, probability of even numbers, you can use 1, subtract the probability of odd. And in this case, okay, just take note. For part B, this is the event that you want. And you use the total probability, which is 1. Subtract away the probability that you don't want. Okay, this is the probability that you want. So you use the total probability, which is 1, minus the probability of odd, which is the case that we don't want. Okay, now part C, probability of prime numbers. So just count, okay, the outcomes which are prime numbers. That gives you 5 out of 12. Multiple of 4. Okay, you have 9 out of 36, so which is 1/4. Probability of at least 7. Okay, 7 out of 12. So from part A to part E, as long as you have drawn out this possibility diagram, I think it makes our collation easier and you will not miss out any of the numbers. Okay, in summary, a possibility diagram is a grid on the left or table on the right to list out the sample space or to list the required possible outcomes. So other than addition, you can do subtraction, division, multiplication, okay, by using the table on the right. Now, this is very useful if it just involves 2 objects or 2 actions. Okay. And just now, like our odd and even example, okay, we use the probability of not the event. Okay, we can use 1 minus the probability of the event. Okay, but these two must be complementary. Like, for example, probability of consonants. Okay, you can use 1 minus probability of vowels.